Hello. So I think we can start the class for today, and we'll be looking at decision trees and random forest models. So I'll explain how these models work and what they are made up of. So far we've covered classification and regression tasks. So maybe I can summarize what we've looked at so far, then we can go ahead and have a look at what decision trees are and what random forest models are. So here we have the machine learning part. Okay, we have the machine learning part. Okay, let me admit someone. So we have the ML part. And for ML, what we've looked at so far is regression, and the other thing we've looked at is classification. So those are the two things we've looked at. And for regression, this one that we have here. So this is made up of numbers which are continuous. Okay, so they are made up of numbers which are continuous. Then for classification, we have distinct values. So basically, it means that we can clearly separate maybe a boy from a girl. Then for this one, we have 1 to 100. So we can predict this using regression. Then we can predict if you are a boy or a girl using classification. Okay, so apart from that, we have some other things we've discussed. So we have the regression models. And for regression models, we've looked at linear regression. And we have the classification models. So I'll just use the short form. So classification models. So here an example is KNN, but we will discuss other models in detail. Okay, so apart from that, you've learned how to pre-process data, and to pre-process data is clean it. Okay, so my pen is misbehaving. So you clean the data. Again, what do? You split the data. So you split data into training and test set. Yeah, so those are the things you learn. Then after splitting data into training and test set, you import your model. So that's all for machine learning models. So what we've covered so far. So today, what we are going to look at is the decision trees and random forest. And we will start with the decision trees. So what are decision trees model? So first of all, what I'll have to do is pick an individual in this class. So let me see. So maybe we can pick, let's say, Sandra. And I'll say Sandra has an income of 400,000. Yeah. So Sandra has an income of 400,000. Then here we have some options. So we have option number 1. Then it has some branches. So that we can have something like that. So here we want to make some predictions on how Sandra's life is. So for example, this top part can be something like, where does Sandra want to live? So home. So we can have something like home. So this is the first decision that we'll have to make over here. So Sandra has an income of 400,000. So here we have two options. So he can either own one, which is this path, that we have here, or she can rent one. So sorry for that. So she can either own one or she can rent one, right? So depending on her income. So I will say we should own a home instead of renting. So I'll go this way. Then something else we need to see is something like, maybe this part here, we can have something like food. Okay, so for food, let's say with her income, so should she do the farming, which is this one, or let someone else do it? So I guess maybe we can let someone else do it based on the income that she has, because she can pay someone to like do that work for her. And then it continues on and on. So what we have here are the different decisions we are making based on this income that we have up here. So that's what a decision tree is made up of. Then we have the root node. So this is the root node, the one that so let me change the color. So this one here is the root node. So where we make our first decision, right? And also we can say this is the parent node. Then here we have branches. So these are the branches, and that's the reason as to why it's called the decision tree. Then down here, so this part here where we have the last decisions being made, I think that should be called what? So let me check. Okay, so we have the leaf node. Yep. So these are the root nodes, then this is the leaf node, so which represents the final decision made. So basically that's how a decision tree looks like. Then apart from a decision tree, so what we will have is next is a random forest. And a random forest is a combination of these multiple decision trees. So this one multiplied by, let's say, 10 gives you the RF, which is the random forest. Okay, so this times 10 will have varied decisions. So we won't have like same decisions being made. So that gives you a random forest. And another thing you need to know is random forest and decision trees can be used to perform both regression and classification tasks. So you can use random forest and decision tree models to perform classification and regression. So you need to keep that in mind. Okay, so let's go to the practical part and see what we can do. Or maybe we can just quickly go through the notes that I have here and see what we have. So decision trees are a popular machine learning algorithm used for both classification and regression tasks. So I've mentioned that already. So they work by recursively splitting the data into subsets based on the values of the input features and then making a decision or a prediction. So it's more of a decision and not a prediction at the leaf nodes based on the majority class or average target value of the samples in each leaf. Yeah, so here we have the key concepts. So we have the nodes and the splits. So as I've shown you, these are the nodes. So we have the root node, we have the leaf nodes. Then the splits are these lines that you see here. So those are the splits. Then we have entropy and information gain. So these are things that are added to the model to like make your predictions be more precise. So these are hyperparameters. So I've defined each and every one of these down there. Yeah, so let's skip this part for the practical part. So we will do that practically ourselves. Then we have the key concepts of decision trees. So we have the nodes and the splits. So a decision tree is a hierarchical structure consisting of nodes connected by branches. So each internal node represents a decision based on the value of a specific input feature. So the tree recursively splits the data into subsets, with each split corresponding to a specific value or a range of values of the input feature. So leaf nodes represent the final prediction or decision, which is based on the majority class. Okay, so maybe we can have a look at a diagram in Google. So I can search for decision tree, then we can see this diagram here. So we have the root node. So just as I had mentioned, so here I believe this is a good example. So I'll open this image in a new tab. So here we have the age of a person, and maybe we are trying to estimate the risk of this person getting a heart attack. Okay, so here we have individuals who are less than 18 years old. We have individuals who are at age between 18 and 30, and we have individuals who are have an age of greater than 30. So we want to assess your risk of getting a heart attack. So let's say looking at myself. So age, so I'm currently 24. So just give me a minute, I'll be back.
Sorry, I hope you've confirmed this audio so that once we go through the recording, we'll be able to. Okay, okay, cool, thanks.
Yeah, yeah, yeah. Yeah, so I'm copying some few parts from the KNN notebook. So the first part is the data loading. The second part is this plotting part. Okay. so that we can see what we had. Then the next part is the splitting of data into target and features. Let me save that. Then lastly, what else am I going to import? So nothing else. Okay, so we are going to fit our model. So here I'm going to import decision tree classifier, because this is a classification task. Remember, we are trying to predict the flower species. So here we will have from sklearn.tree import decision tree classifier. So D is capital here, T is capital, and C is capital. Okay. Then what we are going to do is we are going to instantiate.
I can see you.
the
You're
classifier.
moving fast.
We are going to have
faster,
our
but it's
tree,
fine.
which starts from
Let's go
decision
back
tree being equal
to. I wanted to
decision tree
understand. No,
classifier.
don't go up.
Then the next thing we are going to do is we are going to fit the model.
Where? No. Just below that. No, when we are plotting. Yes, it's there. The figure size. Why we are getting 18, 12, and 8. That one.
And then we are going to have ypred.predict. Then we can run that. So we have our predictions. So KNN notebook, and I'll copy this part for classification report.
Oh, I get you.
Country model on
nodes,
this data,
right?
we get 100% accuracy. So which means that the decision tree model performs more better as compared to the KNN model. And why is that so? You see, the KNN model works based on distance. It works based on the tree itself, where we have the different decision nodes. So what we can do is we can visualize its decision, and we will have to import some few libraries. So from sklearn.tree,
zooming in and out, right?
Then we are going to set our figure size. Then we are going to do the plot tree. We are going to have the plot tree function, take in the model, take in yes, yeah, this part for classification report. Yeah, yeah, yes. So for fig size, we have to set the height. I don't know, is it right? So we can confirm. So if I say let's have 6 instead of 8, you can see it's the 6 there stands for the width. Yeah.
Decision tree. Is it picking the features randomly, or does it pick the one on in regards
because
to
we can definitely remove
how
this
you
thing here,
arrange
so it's not a must it be there, so we can just do the plot
to specify? Because, for example, let me say what I'm asking. So assuming you have the length, so this length is actually distributed definitely, but at the same time we have it's called what, we have the length, we have the width, right? Exactly. So what if we had started with the width?
You can see this what we have here. Yeah,
like in the next part of our probability,
and now this is our decision tree. So you can see the first feature that we have here is the petal length. So here we are checking if the petal length is less than or equal to 2.45. So if the petal length is less than or equal to 2.45, so definitely this thing will be class setosa. Do you see this orange decision made here? Yeah. And if that is not true, we go to this next part here. So is the petal width less than or equal to 1.75? So if it is less than or equal to 1.75, it's as vertical. So we go to the left and we go that in with the two like this plus this chance of being made here. So you see how this control works like this, taking the variable that you have and comparing it to what you have in the data. And that's how it works when you compose functionalities. This one.
Again, another question. Now, if it has an inbuilt feature that weighs out, or any other feature that has more weight than the other, does the sample size count when doing the weigh out, or when weighing out, or does the sample size not matter a lot? What really matters, especially when you're having, in this case, we are dealing with samples and we have to make decisions.
Yeah.
Every node has a sample, and therefore
Yes.
we have those that could be having equal number of samples, others
You
having
have the
less
width.
number of samples. So does the sample size matter?
Yeah.
Or okay, I get your point.
It's kind of probability. Yeah, right. You are correct. Because this is something, yes, it's something similar to the Bayes theorem. So if you can remember. So what happens here is, like a decision tree has an inbuilt feature for like checking the feature importance. So if a feature is important, then it will appear up here at the top. Yeah. So for example, looking at this, we will get to know that petal length is the most important feature in this data. Then after petal length, the other most important feature is the petal width, which comes in second. So decision tree has an inbuilt mechanism of checking which features are more important, and it adds more weight to those features as compared to those other features which are of less importance. Do you get that? Yeah. Yes. Yes. Yeah. 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 I believe the sample size matters. Yeah. So actually, when you are working with decision tree, so when you are working with any tree-based models, so the more data you have, the results you have. So these are the equations that are doing the sum, the feature importance, like dividing the feature importances of the background, and already have mentioned the entropy stuff. So easy to understand and interpret as the tree
especially
structure can be visualized and the decision-making process is clear. So you've seen that. Then decision trees can handle both categorical and numerical features. So what does this
Are
mean?
we talking about
So we are not
especially when
required to
you
like
let me give an
do the
example.
encoding to fit a
If you
decision
have
tree based model. So we will try that
let me say a
practically
supermarket
just now and see if it's the true.
and you
So
have so
requires
many
little data
branches
pre-processing.
in
So
the same
e.g.
city,
no need for feature
the same
scaling or
supermarket,
normalization.
and
Then
these
decision trees can
branches
also handle
others
missing
sell the
data.
same
Then disadvantages, prone to
type
overfitting,
of
especially when the
products,
tree is deep or when some
or
classes
maybe
dominate
all
the
sell the same
dataset.
all
So
sell
here
the
you can
same
see
there is a
it's talking
specific type
more of the
good that is
data.
sold there or
So
product
when
in all these assuming
your
that we
data
are
is filled with,
and again among that one we have specific services that
which may
when you
not
buy
always provide the
this
best
type
separation between
of
classes,
products
then
given
can be
those
sensitive to
services
small
in other
changes in the
branches in
data.
the same city and
You
you're
see
not
this
given
like
in
your
other
sample
branches in
size
the same city,
affects the model,
does it
so
bring
can
it
be
the
sensitive to
same
small
way?
changes in the data,
Because I'm
leading
going
to
to believe it
significant
because this
changes in
branch
the
has
tree
the same
structure.
usage
So that's
type.
why I was saying the more the data, the better the results. So may not perform as well as other algorithms. So e.g. ensemble methods. So ensemble methods are, so this is the decision tree. Then ensemble methods are like fitting a random forest model or something like the XGBoost or the AdaBoost models. Yeah. So those are the advantages and disadvantages. So let's have a look at this. So let's use a data that has, yes, 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 yeah, okay, yes, y- yeah, 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 mhm, yeah,
I got it. Yes, I got it.
no. So it's not based on that. So if we go back to our code, let me explain the tree depth in detail. So here we have a tree depth of, so here you can see how many decision nodes are there. So we have the root node 1, 2, 3, 4, 5, 6. So we can say that this decision tree has a depth of 6 because we have 6 different nodes. So this is the first node, second node, third node, fourth node, fifth node, and sixth node. Okay, so if we look at this part here, so petal length, how many times does it appear? So it appears on the first node where we are checking the less than or equal to 2.45. But also on the third node, it's also appearing there where we are checking the petal length if it is less than or equal to 4.95. Is it appearing elsewhere? So is it there again in the model? So it's not, we can't see it again there in the model. So petal length has appeared twice. So if we wanted to like make this petal length appear only once, we will delete this node that we have over here, which means this decision tree will become shorter. So it will have 5 nodes instead of 6 nodes. and that will affect the score of your, so the score that you will have here. So what this disadvantage is the deeper the tree, so the more these things become repetitive. So the more you check the petal length, the more your model is prone to like overfit. Do you understand what now the depth means? Yeah. It's like a repetition where you are checking your features over and over again instead of like focusing on other things. Yeah. Any other question based on what we looked at in the notes? Okay, so we have no question. So thinking of maybe giving you guys this task as an assignment. So what I want you to do is filter. So you'll proceed from here. So fit a decision tree on the below dataset. So we want to prove something. So we want to prove if this data can handle both categorical and numerical columns. Then see if it's not a must, we normalize the data. So I believe we haven't covered the data normalization, and see if the data, it can handle missing data. So what I'll do is I'll import the, so load the load underscore Boston. So we can have Boston. See, we have an error. Okay, so import load Boston has been removed from scikit-learn. Okay, so let me fetch the data from the original source. Okay, or we can use the California housing data. I guess that's the updated data set. Let me see if that works. California.
Meanwhile, as you look through the dataset, Joseph, sorry, I would like, not today, definitely, but to get some other day. Remember the other multiple linear regression we are doing? Yeah, we actually do it and we get a more explanation on it. And at the same
So we
time,
have the target column.
that this
So
is my
I can
request. I
delete
don't know what
this.
others feel like, but this is my request. Can you give us an insight of how this exam is? Because for the project, I think we can work around. All right. Then now let's go to the exam. Do we have kind of
So this is not okay. So we can't use
what
this
can you
data
tell
because you
us?
can see we
We
don't
have
have
samples
like,
that we can go through
we
so
don't
that we
have the
don't get
categorical
what we call the
and
culture shock in the exam. and
We don't have the categorical and numeric features.
anything.
So
Maybe we
let
can
me
get
go to the
5 or 3
sklearn
samples, and then
documentation site and
I
see
think we can
the
go
kind
through
of
it
data
and we
sets
can
we
be able
can import.
to know what we need to do. We don't need to be stagnating there and
Get
failing
data
and redoing it,
sets.
especially the theory. So it's my request. I'm not saying you answer it now. You don't need to answer that now. It's a request that please, if there is something, if there is what the past papers or what or what
I'm
we need
trying
to
to
do,
see if we
all
can
those
get another
things,
data
you
set
can
that
send
we
them to
can
us. We
use.
can have our own times and we can do them and we can go through them and see how this exam is always like, how it can be tackled, what we expect, so that we get our mindset be prepared on the same. Yeah.
Yes, yes. Yeah, it's okay. Yes. Yeah, the other task that we were doing. Yeah. Yes. Yeah.
That's theory now or the project? And also, sorry, on the project, is it like time based, like 2 hours, or it's something? Oh, and that one you can be helped like now by you? Ah, okay. Question, Joseph. So, can you just use any library to get the data set, or if because we're doing machine learning, it has to be from the scale? Oh, okay.
Yep, I get you. So this is an example, but I'll share it with you so that you can go through it. So some business questions from your board. So you have been given a data set, then you have been asked some questions. So these are maybe some of the key questions you need to ask. So which vendor or plants are causing the greatest defect quantity? Which vendors or plants are causing the greatest downtime? Is there a particular combination of material and vendors that perform poorly? Is there a particular combination of vendors and plants that perform poorly? Yeah, so things like that. So I guess this is one of them. Another one, let me see. This is the project. So for theory, no. Something like a week. I don't. It should be more than it should be a week or 2 weeks. Yeah, yeah, I can help you. Yeah. Then we have something like this, but I guess I've filled this one, so I'll share it with you. So let's which library should we use? So let's use Seaborn. Yes, yes. You can use any library or you can download from online. So we'll have Titanic being equals to sns.load underscore titanic.head. So here I'll define for you the target and so the feature, the target column.
No.
So we've done classification, right? So today what I want you to do is create a classification model that can predict the